So in this lecture, I'm just going to show you that if a matrix is not consistent in the analytical hierarchy process, so how you will make it consistent. So in the previous video, which is on related to analytical hierarchy process, in that lecture I have already discussed the application of analytical hierarchy process. We construct a pairwise comparison matrix and then we check, we normalize that pairwise comparison matrix, then we find out the priority vector, and then from the priority vector we use consistency ratio. And consistency ratio, if the consistency ratio, so I mean you can see if the consistency ratio, which is equal to Ci divided by Ri, if it is less than 0.1, the degree of consistency is acceptable. Otherwise AHP is not meaningful. AHP will not be so feasible in this specific problem. So now the question is how to make a metric consistent. So there are different methods. Different researchers uses different method. They derive different method to make a metric consistent. So ways to understand whether a metric is consistent or not. First of all, you need to calculate matrix rank. So I hope that you understand how to calculate matrix rank. There are different techniques, different software are available in which you will feed the matrix, and when you click that, it will calculate matrix rank. And you can also calculate eigenvalues. So matrix rank, eigenvalues, there are different methods from which you can understand that is a matrix is consistent or not. So one way in order to make a metric consistent is that in order to check that a matrix is consistent or not. So consistent matrix, for example, would look like that in this matrix you can see that the matrix has rank 1. So if it is a 5 by 5 or 7 by 7 matrix, you need to check that what is the rank of that matrix. So in this example, the rank of this matrix is 1. That means that all rows are multiple of each. So I mean you can derive all other O's from one specific row, or you can derive all column from one specific column. For example, multiply with the first column with 3. So you will get the second column. 3, 1, 3 by 5. Multiplying first column with 5, you will get the third one. 5, 5 by 3, and this will be 1. Okay? Or divide first row with 3, so you will get the second row. 1 divided by 3, 1, and 5 by 3. Or divide first row with 5, so you will get the third row. 1 by 5, 3 by 5, so 5 by 5, so it will be equal to 1. So this is the identification to check that a matrix is consistent or not. That means that all rows are multiple of each other and matrix can build from one row. If this is not the situation, then you can use another approach which is called geometric mean. So you are well aware with the geometric mean application. What is geometric mean? So you already studied that in statistics, in mathematics. For n number, multiply them all together and then take the nth root, and we denote this with n. So for example, if we have 1 into 2 into 4 into 5, for example, we have 5 number. Okay, then what you will do? 4. Because 1, 2, 3, 4, we have 4 number. So multiply them all together and then take the nth root, and we normally write this with this way. More formally, the geometric mean of n number a1 to an is n. So as I already discussed this example. Then what you will do? So how you will use this? Normalize each column, compute geometric mean of each row. So before, if you remember, we have just calculate when we take the average of normalized matrix rows. So now you need to calculate the geometric mean of each row. You remember the analytical hierarchy process, we just take the average in order to calculate the priority vector. Now you need to compute geometric mean of each row and renormalize the result. So in this example, this is a very simple example. What we do, we just normalize it. How we will normalize it? The sum of this and divide each element of this column with the sum of this column. So you will get this. The sum of this column, then you need to divide each element with the sum of this column, and similarly sum this column and divide each element with the sum of this column. So this is normalized. Then in the second step, you need to calculate geometric mean 0.65 into 0.69 into 0.56 square root and power 1 by 3 or square root 3. So this is the result which we calculated from the geometric mean. Then I use renormalized result. So how we will renormalize the result? Take the sum of all this and divide each element with this. Then this will be the you need to use this in the lambda. It will make your matrix consistent. The second approach is consistent eigenvalue method. This is a little bit complex method, but if you try to understand it, I don't think so it will be difficult. The number of non-zero eigenvalue for a matrix is equal to its rank. Consistent matrix, as already mentioned, has rank 1. The sum of eigenvalues equal the sum of the diagonal element of the matrix, all ones are consistent. So you not need to go at the manual method to calculate eigenvalue of a matrix. It's a complex problem, so you not need. There are different software for this. Therefore, an inconsistent matrix has one eigenvalue with value n. Inconsistent matrices typically have more than one eigenvalue. Lambda is the eigenvalue satisfied if this is satisfied. I am just giving you a simple example that how you will calculate. So please go to this link. This is a calculator tutorvista.com eigenvector calculator. Compute the eigenvalue for the inconsistent. This is now inconsistent matrix. Okay, so you can put, if this is consistent or inconsistent, it doesn't matter. Just put this matrix in this software, calculate the eigenvalues. So mean for the eigenvector and normalize. When you normalize it, you will get these values. Okay, these are the eigenvalues different than before. And then what you will do, you will take these values and you will use these values as a priority vector, just like we did in the geometric mean. So you instead of, so in the geometric mean we use these values, renormalized value. In the eigenvalue eigenvector, you need to use these values. Okay, and then you need to do the rest of process. Lambda, you need to calculate that, and you need to calculate the consistency ratio, so it will make the matrix consistent. I hope that you will understand this, and if you have some difficulty, then you can contact me. Thank you.